Hello everyone, welcome back to the channel. This is another video in our data sectional algorithm series, right? In our last video, we were able to implement the methods to remove the node from the linked list. We have seen how do you remove the node from the beginning of the linked list. You have also seen how do you remove the node from the end of the linked list, right? The implementation was super easy, right? I hope you are able to understand that. Now, as part of this video, we are going to implement a method called size, right? To get the size of the nodes that we have in our linked list, right? Now that is actually super simple to implement. We will just return that particular size variable, but I'll show you why we did in such a way. So let me implement that method first. Public int get size, and in this method we will straightforward return this size variable, right? So now if we try to get the value, that means 2, you see we already removed two numbers, right? Any two variable, remove last and remove first. Remove last 30 we remove and remove first 40 we remove. Now we should have only 10 and 20, that means the size should be 2. So if you try to print the size of the linked list, right? List dot get size, we should get 2, right? Let's hope we get 2, and we are getting 2. That means our size implementation is correct. But how we are able to do it in constant time? You see, when we were adding and removing the element, right? So we have implemented initially these two methods, add last and add first, right? There we, in the method itself, we were increasing the size of the linked list, right? We have taken a variable there itself. And when we were trying to remove the nodes, right? Remove last or this remove first, right? We were actually reducing the size minus minus. Here we also did size minus minus. That is the reason we are able to calculate it in constant time. Let's say you don't have a variable of size, right? In that case, how you will be able to calculate the size? So what in that case you will do, you will iterate through our linked list. Let me show which method you will be using in that scenario. Let's say let's take any method, right? For example, you are trying to find the index of a particular node, right? You are iterating through the whole linked list, right? When current is not equal to null, you are iterating, jumping to the next node, increasing this index, right? So in the same way, instead of this index variable, you would have taken a size variable, and there would be no condition of checking anything in between. You will be straightforward increasing this size variable until you reach the end of the linked list, and in the end you will return this size variable. I'm taking the reference of this index of variable to explain you what could have been done when you don't have this size variable as part of your implementation. So in that case, you will have a simple iteration. You did not take in a variable this size, right? If you haven't taken a size variable, what would you have been doing? You would be iterating through the whole linked list, and you have taken a variable which you will be iterating with every single node, which you will be increasing with every single node, right? That operation would become O of n, right? So just to simplify it, to calculate the size in constant time, we have taken the size variable, and that is why we were incrementing or decrementing our size variable whenever we are trying to add or remove the node from the linked list, right? And that is how we are able to calculate the size in constant time. This is a very small example of constant time or linear time, right? I have shown you can do the same thing in both of the time complexities, but you choose to do it in constant time because that's better. So yeah, our implementation works perfectly fine. That was not even an implementation, it was just to tell you how we were able to calculate the size in constant time instead of linear time. I hope you are able to understand, right? In next video, what we'll be discussing, we'll be converting our linked list to an array. It's a very simple implementation again, right? So see you in the next video. Meanwhile, what you're going to practice in this particular method, let's just try to understand the previous methods like adding or deletion the nodes, so that you understand why we incremented and decremented there, so that we can calculate the size of the linked list in a constant time, right? So yeah, may the source be with you. See you in the next video.